Let's wrap these up with maybe a simpler example before we do an example of solving an entire differential equation with Laplace transforms. So one more, finding an inverse Laplace transform, and this one is relatively straightforward. All we have to do, if you notice, we have this denominator that is already factored for us, so we need to do some partial fraction decomposition to break this up into smaller pieces. So let's do that partial fraction problem. We've got 7s minus 1 over s plus 1, s plus 2, s plus 3. So they're all three distinct factors, no repeated factors. So the partial fraction decomposition is as simple as each factor gets its own fraction with a constant numerator. And again, if, for instance, we had one of these factors was an irreducible quadratic, the numerator here would need to be linear, and so on. But for this one, we don't need to worry about anything like that. So to continue through the partial fraction problem, we would multiply both sides by this denominator, and that gives us 7s minus 1. And then on the right-hand side, we'd have a, the s plus 1 cancels on that term. On the b term, the s plus 2 cancels. And on the c term, the s minus 3 cancels, or plus 3. It should be plus 3, sorry. Actually, to do the problem, I wanted to make it minus 3. Sorry, let me fix those. Okay, so that should be right now. So then to make this work, to find a, b, and c, again, we have a couple options. We could distribute everything through and then set up the system of equations. But the way I prefer to do it, we're going to select values of s that are convenient. So we'll use -1, -2, and 3. Again, relying on the fact that if these two things are equal, they have to be equal for all values of s. And these values are the most convenient to use to solve for a, b, and c. So if s is -1, the left-hand side would give us -7 minus 1, or -8. On the right-hand side, the b and c terms would both disappear, and we would just have a times 1 times -4. So -4a equals -8, which means a is 2. Similarly, if s is -2, the left-hand side would be -14 minus 1, or -15. On the right-hand side, the a and c terms would go away. We would have b times -1 times -5. So 5b equals -15. So b is -3. And lastly, if s is 3, we'd have 20 on the left side, and on the right side we would have c times 4 times 5, which tells us that c equals 1. Which means that when we look for the Laplace, or the inverse Laplace transform of this whole piece, we can instead break it down as the inverse Laplace of 2 over s plus 1 minus 3 over s plus 2 plus 1 over s minus 3. And at that point, all three of those are simple exponential terms. So let me break out the 2 and the other coefficients as well. And just as a reminder, the inverse, or the Laplace transform of e to the at is 1 over s minus a. So this first one, a would be -1. The second one, a would be -2. And the last one, a would be 3. So that one, the algebra was not nearly as complicated as the last example. All we have to do is do some partial fraction decomposition, which we've done many times to this point.